Hi, kids. Hey! I'm here to talk to you about angular momentum a little bit more, and specifically how linear objects can have angular momentum and how that angular momentum can stay constant before the collision. So that's what we're going to talk about. So let's say I have a bar here, axis of rotation right there. We've already talked about in a previous video that, hey, if it's something is moving right here, it's not going to have angular momentum. Why? Because it's not going to exert a torque. If it doesn't exert a torque, you can't have an angular impulse. If you can't have an angular impulse, it's not going to change its angular momentum, which means it doesn't have any angular momentum. Same thing if something hit here or something hit here, no big, hopefully that makes sense. But if I have an object, a ball, that is moving this way, and it's moving in a straight line, and it's going to hit here, well, right before the collision, here's what it would look like. It would be here and moving that way. Well, if I wanted to figure out its angular momentum right there, it definitely has angular momentum. Why? Because it will exert a torque on that stick, and if it exerts a torque on the stick, then the stick is going to have an angular impulse. If the stick has an angular impulse, its angular momentum is going to change. Therefore, this ball had to have angular momentum. Well, if I wanted to draw in the lever arm for that, that would be my lever arm. And if I wanted to write my equation, I would have L equals I times omega. So L for the ball, I would be mr squared, because all of the mass is a distance r away. And then this, we did this before, so I'm not going to do it right now, would be v divided by r, and that would simplify down to mr times v, okay? Which would be, this is the angular momentum of that ball right before the collision. Well, guess what? If the angular momentum of the ball right before the collision is this, that means the angular momentum over here also has to be that, because the angular momentum doesn't change, because there's no outside force acting, there's no outside torque. So how is that possible? So let's draw in the lever arm for this. So this, okay, there's the lever arm, okay. If you look, well, that's a way bigger R. Yeah, it is. It's a way bigger R. So if I was to do mRV for this guy, well, this is much, much bigger. This is the same. That's much, much bigger. So the only way that this can be the same as mRV is if this is much, much smaller. Which you might think, well, wait a second, that's the same V. But the V that is going to cause the torque is just the perpendicular component of the V. So if I was to draw that, it would look something like this. So this V is much smaller than this V, which allows it to, this equation to equal out to be this. If I was to draw it, let's say right here, again, the angular momentum right here has to be the same as there and there. If I was to draw in my lever arm, there it is. If I do the same process, all right, well, if I have mRV, well, again, this R is, not as big as the green one, not as is bigger than the black one, but that means that this V, if you do it, it would be this component is the one that's going to cause the torque, okay? So that this would be in between, and that's how they all can be equal, and hopefully that makes sense. So mathematically, as this thing moves closer, R is getting smaller, but the component of V is getting bigger, that V and R are perpendicular. Okay, conceptually, if you were to think about this, as this thing moves here, like out here, it has angular momentum, and its angular momentum would be like, hey, it's rotating around there. Hopefully we see it's rotating counterclockwise, but the only piece that's causing it to rotate counterclockwise is just this itty bitty piece. Okay, where here, that itty bitty piece got a little bit bigger, causing it to still rotate counterclockwise, and now all of that V is going to cause it to rotate counterclockwise, and hence why the angular momentum of this linear object stays the same before. I hope that makes sense. Bye, kids.